Children, you might be knowing that in the recent survey done on the several cities of our country, Patna has been found dirtiest. That's a matter of big shame and embarrassment for we Patnaites. So simply I say that if you can't clean your surrounding, then don't make it dirty as well. Children, as you all know that we are studying the laws of chemical combination, and we have gained a good knowledge over the law of conservation of mass and its numerical part as well, and we have seen that it has found to be verified under every condition. So we are moving ahead in the same sequence, and today I have brought the next law of chemical combination, and that is a law of constant proportion. Children, so what is law of constant proportion? We will have a great discussion over it, and we will cover up its all aspect and its analytical part as well. So law of constant proportion has the basic two words, that is your constant proportion, and in the law of conservation of mass also had in its statement that the constant mass. So here mass is not written that the law of constant proportion by mass, but actually it is about the mass only, children. It is about the constant proportion by mass, and that mass in what type of substance or chemical reaction, I will make it clear soon. So what was Lavoisier's study? That during a chemical combination, the mass of the reactants and products are always coming equal, and it was verified in the all type of chemical reaction, and that part we have seen it very well in the while the solving numericals of on law of conservation of mass, where I given you different kinds of numerical on the different types of chemical reaction, and we seen that under every type of chemical reaction the mass was coming as equal, constant, and it was conserved. So it given us this concept that mass cannot be created and destroyed during a chemical combination. Now in the Lavoisier along with other scientists, what he observed again, that in a compound, here we are not talking about the chemical reaction or chemical combination. Look, the study is going to be fine to finest. It has started with the chemical combination, and it is moving, taking an U-turn towards just a compound, means just a substance. So we are heading or moving towards in a precise way only to find the last particle of the atom, children. This is the study which will achieve success in finding the last particle of the matter, which will be your atom, no doubt about it. So what was Lavoisier's observation? That in a chemical compound, the elements which are forming that a particular compound, suppose that if I am saying quicklime, then what is forming quicklime, children? It is only calcium and oxygen. If I am saying oxide of sulfur, then what is forming oxide of sulfur? Sulfur and oxygen. So these are the compounds. If the compound is made of two elements or more than two elements, irrespective of that, what is the number of elements? The elements are always combining to form the compound in the same proportion. In the same proportion for a particular compound. How? I am telling you, like you have a compound of hydrogen and oxygen, which is water, and you have a compound of hydrogen and oxygen, which is your hydrogen peroxide. You have compound of sulfur and oxygen, that is your sulfur dioxide, and you have a compound of sulfur and oxygen, that is your sulfur trioxide. So if the proportion is changing, the compound is changing. If a compound is combining in the fixed proportion, the single type of compound will be formed. If the composition, if the proportion is changing, another compound will form. And that is why for a particular compound, the proportion of the element always has been found fixed in a definite proportion by mass. Here also I am saying by mass. How? I am telling you again that this was the observation of Lavoisier. He could not perform much experimentations over it, but the thought of the Lavoisier, it was the thought of Lavoisier, but it was the work of Joseph Proust. He started studying only the compounds, not the chemical combination, boys. He started studying about the compounds, and finally, while studying numerous chemical compound, what conclusion he achieved by 1779, that he came in the position to postulate a law, to give a law, formulate a law, postulate a law, establish a law, and that law was also commonly called as Proust law, or law of constant proportion, or law of definite proportion as well. Here you will not confuse, they all are same. So what was the milestone he achieved by giving this statement? The statement, first we will know that the statement was that a given chemical compound always contains its component elements in fixed ratio by mass and does not depend on the source and method of preparation. So now try to understand. If we are talking about a chemical compound or a substance in a common language, then a particular substance can be obtained from the different sources. A same compound can be produced by the different methods. This is true. I am giving an example of water. That water you can get from the rain, also can from the oceans, lakes, rivers, ponds. From the muddy water also you can get the water, and you can purify it by separating it through the right separation methods. But they all are water. What is their composition? It is made up of hydrogen and oxygen. And what will be the ratio of hydrogen and oxygen has been found always coming in the ratio of 1:8. It was found that from irrespective of the source from where the water has been obtained, nothing has to do with the source. Whether you are taking just the tap water from your kitchen, or you are collecting some rainwater from your rooftop. The water, when it was decomposed, it was found to contain 8/9 of the mass of oxygen and 1/9 of the mass of hydrogen. So finally, what was the ratio? Ratio was 1:8. And it was found equally proven everywhere and in every sample of water. I am giving a stress that in every sample of water, this was found that when water is decomposed, how it is decomposed, I am telling you what miracle Proust has done to reach to the atom, which has helped a lot Dalton, who finally given the Dalton's atomic theory. So what was Proust's observation and experimentation? That he taken many types of compounds available in the surrounding from the ores, from the different sources, and then he tried to decompose them into their corresponding elements. So it was more targeted, children. Whereas in the Lavoisier's work, the compound were allowed to combine chemically, to do the chemical reaction and to form the different compounds only. So it was found that the mass was coming equal, conserved, and because of the mass of the elements were fixed, its atoms were fixed, so it was coming equal. But to find the ratio by mass of the particular elements present in a compound, he tried to study it only upon a single compound instead of going on the chemical combination. So what was the very you can say targeted method to do this type of experimentation? It was not easy, I am telling you, because he started the electrolysis process also. So he started electrolysis process, and by the electrolysis he broken down the compounds into its corresponding element, and those elements which were making cations were going towards the cathode, and those elements which are making anion were collected at the anodes, because the anion are the negatively charged, so it will go towards the positive terminal anode, and the cations are the positively charged, so it will go towards the positive terminal cathode. So what he studied, that when he was decomposing water taken from the different samples, I am telling you what can be the possible sources of water. I have already given you idea, whether it is seawater, rainwater, tap water, or whatever water, groundwater. The particular water from the every sample is getting decomposed to come as in the proportion of 1:8 of the ratio by mass of its element hydrogen and oxygen. So means a hydrogen and oxygen is always coming in the mass of the hydrogen and oxygen is always coming in the ratio of 1:8 by mass. Whatever sample we have tasted, we have electrolyzed, we have decomposed. This was found. And it was found proven everywhere from the sample of the water taken from any source. It was coming as in the ratio of 1:8. It was not having any difference whatever is the sample taken. So here I have tried to give you the examples of the different compounds and the sources from where they can be taken. So a very common compound, children, is your carbon dioxide, and then you start to study upon the carbon dioxide. What can be the possible sources of carbon dioxide, children? It can be produced by the respiration. We exhale carbon dioxide, we take oxygen, and so that's why the respiration has a byproduct carbon dioxide. Then in the second source, if we are talking about, then burning always produce carbon dioxide. Carbon burns in the presence of oxygen, gives carbon dioxide. You all know it very well. Then the third source, possible source can be by heating limestone. Limestone, which is your calcium carbonate or calcite, when it is thermally decomposed, when we heat it strongly, then it gets decomposed into what? Quicklime, which is your calcium oxide and carbon dioxide. So here also carbon dioxide emission is going on, evolution of carbon dioxide. Then it can be produced by heating sodium bicarb, soda bicarb, or sodium hydrogen sulfate carbonate also we call it, which is also called baking soda, children. So if we heat strongly sodium hydrogen carbonate, then also it will get decomposed into sodium carbonate, water, and carbon dioxide again. Then it can be produced if we chemically combine calcium carbonate to the dilute hydrochloric acid, and then a salt will form, calcium chloride, and then carbon dioxide will be produced and water. So what you have seen commonly, that in every source carbon dioxide is getting produced. By every source carbon dioxide is getting produced. So now we will study upon the carbon dioxide which has been collected from the different sources, and then we try to find that what is the truthfulness of this law. So what has been found, that the carbon dioxide that has been obtained from these different sources is keeping carbon and oxygen in the ratio of 3:8. Because why I am writing 12 here and why I am writing 32 here, children, that also I am telling you, that in the carbon dioxide there are 2 atoms of carbon and 2 atoms of oxygen and 1 atom of carbon. And little much I am going beyond the topic also, because the atomic mass reference here becomes very important. Every atom has its fixed mass, I have told you, and that mass is called your atomic mass. So the atomic mass has been already calculated, and these atomic masses are fixed for a particular element. That is why the mass remains conserved, because the atomic masses are fixed. Are you understanding? So carbon has the atomic mass as 12 unified mass, and the oxygen has its atomic mass as 16 unified mass, and there are 2 atoms of oxygen. That is why it will be 16 into 2, finally 32 unified mass. And when we divide it, then the ratio is coming as 3:8. So this I am telling you in the particulate basis, on the basis of particles, on the basis of atoms. But these atoms are only making the bulk of any substance. If you have, I am telling you that carbon dioxide is taken, suppose that 32 gram carbon dioxide is taken, then what will be the proportion by mass of carbon and oxygen in this bulk mass? It will come as 3:8. Means the division of the mass of the bulk mass of carbon dioxide will be done in such a way that the carbon and oxygen will be keeping the mass by ratio as 3:8. What mass will be of carbon and what mass will be of oxygen in the carbon dioxide will always come in the fixed proportion, that is your 3:8. Whatever is the bulk mass, that bulk mass will be divided in such a way that the mass of the elements will come as a fixed proportion. and that will be found, that has been found in every source of the carbon dioxide, as I have given you in just now that how many sources from where it has been collected. And in the every source it was found that the carbon dioxide which is getting produced or in the different types of chemical changes or by respiration etc. is keeping carbon and oxygen in the ratio of 3:8. So this gives us the imagination of atom also, because the atom, I can agree that at that time the carbon and oxygen atomic mass was not calculated, but now when we know about its atomic masses, we have done much advancement in the study of science and we have complete idea of the atomic mass. Then this is proven, because these are the masses of the atom which is coming in the ratio of 3:8, and this mass will multiply in the bulk mass, and that is why the proportion will always remain fixed there also. The proportion will remain fixed there also. So similarly, in a very common compound ammonia, which has its formula NH3 because it has one atom of nitrogen and three atoms of hydrogen, keeps nitrogen and hydrogen in the fixed ratio of 14:3, whatever is its source. Whether it is produced by the Haber's process, which is the industrial process, or just by the chemical combination of nitrogen and hydrogen, or it is obtained from the dairy where it is used as a coolant. So from wherever you are getting the ammonia gas, it is keeping it will keep, and it keeps, I will say it will not, it keeps hydrogen and oxygen, nitrogen in the ratio of nitrogen and hydrogen in the ratio of 14:3. And due to the reason that nitrogen also has 14 unified mass as its atomic mass, and hydrogen has 1 unified mass, and since the hydrogen is in 3 number of atoms in ammonia, so the final mass will be 14:3 here. So here you can't see any cancellation. So the smallest proportion or smallest ratio will be 14:3, whereas in this case, in the case of carbon dioxide, the smallest proportion was 12/32, so 3:8. So in the case of water, the smallest proportion was 1:8, because the H2O is the formula, and hydrogen is in number of atoms, it has 2 number, and oxygen is 1 number in atom, and then the 2 unified mass is contributed by hydrogen, and your 16 unified mass has been contributed by oxygen in the water molecule. So 2/16, it is coming as 1:8. So are you getting it? I have tried to explain it with my different ways, going little advanced in the topic also, because here the concept of atomic mass has not been introduced, but just to fix the concept into your mind that why it happens, I am telling you, because this is the mass of the atom which is making the bulk mass, and for a particular compound the atoms are arranged in a particular way. The number of atoms will remain fixed of a particular atom, and that is why when we divide their masses, this will also come as fixed in the form of ratio. That you might be getting justified with the way I tried to explain the authenticity of the law, Proust law, or law of definite proportion. Although I am not keeping to the idea given in the law of constant proportion only, but I went little advanced to make your concept clear by taking the concept of atomic mass, because by the concept of atomic mass, it will not create any confusion in your mind that why always it is coming as a fixed proportion, because the masses of the atoms are fixed, and these masses are combined, these atoms are combining in a particular way to form a specific compound, and in that specific compound, if we divide the masses in the form of bulk mass also, then the proportion is coming fixed, because a particular molecule of that compound, the atoms involved in that molecules of the different elements are in the fixed ratio due to its fixed atomic mass. So the better explanation was given by the Dalton's atomic theory, which will be my immediate next topic, which I will take up, and I'll try to open up the results of the or conclusions of the your Lavoisier's law and Proust's law. Because what happened that during that time when the Proust was conducting experiment on the different type of sulfides, oxides and sulfates, somewhere it has got exception also where it proven wrong, because the oxides are the compounds which make chain of compounds due to the higher reactivity of oxygen. So somewhere it has met exceptions also, due to which it was criticized also. But the Dalton, on the basis of its atomic theory, has proved it wrong, and soon it will get clear to you how Dalton concluded and given some discrete postulates, 6 postulates he given, and that is historical in the study of, you can say, atom. And he was the scientist who has given the name atom also from the Greek word atomos. So these things we will study in our coming class, and I hope that today's class has not remained very complex to you, as I have tried to make it easier. So I agree that the topic is little complex, so we will not conclude this topic today. This is just an explanation, not the conclusion, children, because the conclusion will be done by its numerical or calculation basis. On the basis of calculation also, if we will verify, and we will get content that okay, it is coming equally good in calculative way also. So my coming class is nothing else but a numerical class.